Assalamu alaikum. Welcome to my channel Mathematical Room. So in our today's video we are going to find some kind of trigonometric identities that you should know about these kind of fundamental trigonometric identities. So let's start that what are these the fundamental trigonometric identities. As you can see that I have written the heading as trigonometric identities, and some of the fundamental trigonometric identities we are going to find, and these are the basic identities that we should have to know that how can we find out these kind of trigonometric identities. So the trigonometric identities, we shall consider some of the fundamental identities that used in trigonometry. So the key to these basic identities is the Pythagoras theorem in geometry. So as you know, the Pythagoras theorem, what is the Pythagoras theorem? So Pythagoras theorem the definition of the Pythagoras theorem is that we have already studied a lot about the Pythagoras theorem, that I'm going to write down the definition of the Pythagoras theorem, that the square of the length of the hypotenuse the square of the length of the hypotenuse of a right angle triangle is always equal to the sum of the squares of the lengths of the other two sides. So that's the definition of the Pythagoras theorem, that the square of the length of the hypotenuse of a right angle triangle is always equal to the sum of squares of length of the other two sides. So if we draw a picture or draw a diagram of a right angle triangle, so that can be drawn as this shape, that is called the right angle triangle. So let's consider that this angle is theta, and the other three sides, we can say that this side is A, this side is B, and this side is C. So remember that the diagonal line or diagonal side always called the hypotenuse, and the other two sides can be the altitude or base. So or you can say perpendicular. This line is perpendicular and this line is base. So if we're talking about the theta over there, so the opposite side is this one, is called the perpendicular, and this side is the adjacent side, which you can say that this is the base of the right angle triangle, and this line is always considered as the hypotenuse of a right angle triangle. So according to the Pythagoras theorem that says the square of the length of the hypotenuse, though, so we can say that this side is hypotenuse and the square of this side is always equal to the sum of square of these two sides. So by Pythagoras theorem, we can say that square of the hypotenuse, so the square of the hypotenuse C, so we can say that square of the hypotenuse always equals to the sum of square of other two sides. So these can be written as, in mathematical form, that C square will always be equals to A square plus B square. So that's the thing where the perpendicular equals to the length A. So this is the perpendicular, which is representing with small a, and the base is equal to small b, and hypotenuse is equal to C. So by using the Pythagoras theorem, we can say that C square is equal to A square plus B square, or we can say that A square plus B square is equal to C square. So now we are going to find some fundamental trigonometric identities that we use we will use these identities in our coming lectures to find some kind of formulas of the trigonometric ratios. So what we are going to do, we are going to divide one by one with A square, B square, and C square as the Pythagoras theorem given in front of you. So if we take the first step by dividing C square on both sides, so by dividing C square on both sides, so the formula of Pythagoras theorem can be written as A square divided by C square plus B square divided by C square is equals to C square divided by C square. So this C square will be cancelled with this one. So now we can say that A square over C square plus B square over C square is equals to 1. So now With the help of this right angle triangle, we are going to find the trigonometric identities. So a square representing the opposite side, and c square is the hypotenuse. So, and b representing the base. So by using these words SOH, CAH and TOA. So if we see that a square over c square, a square over c square, so sine will be equals to a over c. Sine means sine theta is equals to opposite side divided by hypotenuse. So that is the opposite side, and this one is adjacent side, and this one is hypotenuse. So we can say that a square divided by c square. So we can say that sine is equals to opposite over hypotenuse. So we are going to write sine square the angle is given as theta, so sine square theta plus b square over c square means b is adjacent side and c is hypotenuse. So cos, using this word, c for cos, a for adjacent, h for hypotenuse. So we can say that the adjacent side divided by hypotenuse. So the adjacent is b and hypotenuse is c. So we can say that cos square theta is equals to 1. So that's the first trigonometric identity that we have found with the help of this right angle triangle as the sides given as a, b and c. So we can say that sine square theta plus cos square theta always equals to 1. So that's the first fundamental trigonometric identity. So we have found to divide the formula of Pythagoras theorem by c square. So now in our next step that we are going to divide the Pythagoras theorem with b. So a square plus b square is equals to c square. So by dividing b square on both sides, if we divide a square plus b square plus b square plus divided by b square is equals to c square divided by b square. So this will be cancelled with this one. So now the a square divided by b square plus 1 is equals to c square divided by b square. So that's the way we have to find the trigonometric identities. So the second trigonometric identity will be a square divided by b square plus 1 is equals to c square divided by b square. So now a and b, what are the a and b? Opposite over adjacent. So if we say that T O A, T for tangent, O for opposite, A for adjacent. So we can write tangent square theta over here plus 1 is equals to C square over B square. C is hypotenuse and B is adjacent. So if we say that by using this word CAH, cos is equals to adjacent over hypotenuse. So the reciprocal of cos is secant. So secant will be equals to C hypotenuse over B adjacent. So C square over B square will be equals to secant square theta. So that's the second fundamental identity that we have found with the help of this right angle triangle. So now if we divide to find the third fundamental identity, we will divide the Pythagoras theorem by a square. In first, to find the first fundamental identity, trigonometric identity, we have divided the Pythagoras theorem by c square, and then in second condition we have divided by b square, and now we are going to divide the Pythagoras theorem with a square. So by dividing a square on both sides, so that will be equals to a square divided by a square plus b square divided by a square is equals to c square divided by a square. So that will be cancelled with this one. So we can write as 1 plus b square divided by a square is equals to c square divided by a square. Now by using this right angle triangle, we are going to find the third fundamental identity. So that will be equals to 1 b square over a square. So let's see, b over a. So opposite over adjacent is always equals to tangent. So if we reciprocal the tangent is cotangent, then the sides will also be changed into reciprocal form. So b square over a square will be equals to cotangent square theta is equals to c square over a square. So c square over a square, let's have a look on this figure. C square over a square, or c over a, hypotenuse over opposite. So hypotenuse over opposite will be equals to the reciprocal of sine. So reciprocal of sine is cosecant, and we can say that hypotenuse over opposite. So hypotenuse over opposite will be equals to c square over a square. That will be equals to cosecant theta, cosecant square theta. So that's the third identity we have found with the help of Pythagoras theorem. So these are the three fundamental identities which we are going to use in our next lectures, incoming lectures. So how can we find the different kind of identities, or we can solve the different kind of questions with the help of these fundamental identities. So let's have a look on the first fundamental trigonometric ratio, that will always be equal to sine square plus cos square is equals to 1. So remember this thing, sine square plus cos square is equals to 1. The second identity shows that tangent square theta plus 1 is equals to secant square theta. So remember always that tangent square theta plus 1 is equals to secant square theta. That's the second fundamental identity. And the third one is 1 plus cotangent square theta is equals to cosecant square theta. So that's the third fundamental identity. So that's the way we can find the trigonometric identities. So in our coming lectures, now we are going to solve some kind of questions with the help of these trigonometric identities. So stay with me in my next lectures. So I will give some examples by using these kind of trigonometric trigonometric identities. So as you can see that our topic was today is trigonometric identities, and some of the fundamental trigonometric identities we have found: number 1, 2, and the 3. So stay with me and watch my next lectures, that we are going to solve some kind of questions with the help of these fundamental trigonometric identities. So don't forget to subscribe my channel. I will see you in my next video. तब तक के लिए इजाज़त दीजिए। खुदा हाफिज़।